welcome to www.highschoolmaths.co.uk. Today we're going to be looking at how to find the area of some basic two-dimensional shapes. So we're going to start off nice and basic with a rectangle, which is one everyone should know the formula for. So when you're talking about area, you're looking at the space inside a shape when it's full. So here, the area inside this 2D shape, or this rectangle, would be represented by the orange colour here. And we're looking at the area formula for a rectangle being length times breadth. So it's the length of the shape times the breadth of the shape. So area equals length times breadth, which is 4 times 2.5. And 4 times 2.5 would be 10. And your units here would be squared meters. So 10 meters with a little squared sign above it. Okay, all area units are going to be squared. So that's your working, and that's what it should look like. And if you write the working out that way, then it will help you a lot later on when you see the other examples and when you also see some of the other stuff we're going to come on to with area and volume. Okay, let's have a look at another shape. So we've got the area of a triangle. Very similar idea. And when you think about it, a triangle is basically just half of a rectangle. So if I was to draw in the edges here, to join that up, you can see that the triangle is exactly half of the full rectangle that surrounds it. Now, we don't actually want the rectangle there, so what we're looking for is how do we find the area of this? Well, it's a half times the base times the height. Now we use base and height rather than length times breadth, but that's fine, it's the same thing. Some people will use length times breadth. So it's a half times the base times the height, or a half BH, which is a half times. Now the base is the bottom, which is 4, and the height is 5. Now, with this, it's up to you which way you want to do it. Half of 4 is 2, times that by 5 is 10, or 4 5s are 20, half of 20 is 10. You can do it in any order because it's multiplying. But we end up with an answer of 10 cm squared, or 10 squared centimetres for the area of this triangle. Okay, so each shape has a unique formula. We're not going to cover all the shapes here, we're just going to cover a few of the really common ones. Next one's a parallelogram. Now, parallelogram is a nice shape because basically it is very similar to a rectangle. And if we have a look at the parallelogram here, take this part from the end and join onto the other side, what you've basically got is a rectangle. So it makes sense that the area, which is the blue part here, of this parallelogram is just going to be the same as the area of the rectangle we just looked at. And the formula then is going to be very similar. So it's going to be area equals, oh, I don't know what's happened here. Area equals the base times the height. Again, we're using base and height. So the base is 10. The height of the shape is not this sloping line. It's the height from the bottom straight vertically up to the top. Okay, so it's 10 times 4. 10 times 4 is 40, so it's 40 cm squared, 40 squared centimetres. Okay, that's how you calculate the area of a parallelogram. We're going to look at next one, area of a circle. Now this one's quite different. The circle is the only shape that involves pi. So we've got a specific formula for circle too. Area equals pi r squared. Very, very common formula. Pi is the value of 3.14, but we're going to use the pi button in our calculator just to get a bit more accurate. Okay, pi is what's called an irrational number, and it goes on forever and ever and ever. So we want to use the pi button in our calculator to keep things as accurate as possible. But you may have used 3.14 if you've not got a scientific calculator. Okay, so it's pi, or 3.14, times the radius of the circle squared. Now the radius of the circle is the distance from the middle of the circle, which is here, to the outside of the circle. Sometimes it will give you the diameter, it's a wee cheeky thing. Okay, so watch out for that. But here, that distance from the middle to the outside, that's the radius, and that's 5. So it's pi times 5 squared. Okay, don't forget your squared there. Now we just type that into the calculator exactly as it looks. So we're looking for the pi button, and it'll be in different places in different calculators. Pi times 5 squared. Type that in and you should get, and we'll just do it to 2 decimal places just for simplicity just now, 78.54. I've rounded up there because it was 78.539. which means we round up to 78.54. And again, it's an area, so it's cm squared. Okay, that's how we calculate the area of a circle. Now we can do loads of different things with these basic area shapes. We're going to look at a few, but the possibilities are endless. So let's have a look at some composite shapes. A composite shape is where you join two or more shapes together to form another shape. And you see them all the time in real life, because everything's not made up of basic rectangles and triangles. They're made up of more complicated shapes. What we want to do is find the green area here. Now, if you look at that, that doesn't actually represent any of the shapes we've looked at so far. But with one simple change, we pop a line straight down there. Now it does. It represents a rectangle, which we'll call 1, and a triangle, which we'll call 2. So all we really have to do is find the area of the rectangle, find the area of the triangle, and join them together. And that's and add them together, sorry. And that's all we're going to do here. Now you have to be careful when you're picking out your sizes. So we're going to start off with 1, which is our rectangle. And if you look back, the area of the rectangle was length times breadth. So the length of the rectangle is the 12, not the 18. The 18 is for that whole shape. The rectangle is just this part, which is the 12. So it's 12 times, and the breadth of the rectangle was 5. So 12 times 5, which is 60, and again, cm squared. The second shape was a triangle. And if you look back, that was a half times base times height. So it's a half times, now the base of this triangle, it's not 18, that's the whole thing. Okay, so we're looking just from here to here. That whole thing's 18. We know that bit up the top, from there, all the way along to here, that's 12. Okay, so 12 plus what gives you 18? Well, that's got to be 6. Okay, so it's a half times 6 times the height of the triangle, which is 5. We get that from the far side over here. 6 times 5 is 30, half of that is 15, so 15 cm squared. Now I've kept the numbers quite straightforward here so that we can do it quite quickly. Now, that was the area of the individual shapes. The total is what we're looking for. So we're going to add them together. 60 add 15. Okay, so that gives us 75 squared centimetres. Okay, don't be lazy with that last bit. A lot of people just put a wee add sign in here and then put an equals, start dotting things about the place. Keep it neat. It doesn't take long and it makes it look so much better. Okay, so take a little bit of extra time, take a little bit of extra care and pride in your work. Okay, it doesn't take long. And we're going to cover one final example on area. Okay, and for our final example, we are going to look at another composite shape, but we've got a circle here with a square in the middle cut out. And it's the questions in a context, which is quite common with these kinds of area questions. So we're going to have a look at this. We've got a design for a circular trophy is shown below. So this is some kind of two-dimensional circular trophy. Calculate area of yellow paint needed for this shape. So we're going to start off with that. Part A. Now we recognise that there's a circle on the outside and a square on the inside. Okay, so we've got a big circle shape and a square shape there. We recognise our two shapes. That's the first key part to solving these kind of questions. We need to look at shape 1 first. So that's the circle. The area of a circle, which is what we're talking about here, is pi r squared. And we're just going to plug in the numbers here. So it's pi times the radius. Now the radius is from the middle of the circle to the outside. This 20 would be the diameter, not the radius. The radius would be 10. So pi times 10 squared. That's half of the 20. Now you're going to type that into your calculator. That should give you 314.16 squared centimetres, rounded to 2 decimal places. For shape 2, we've got a square. Same formula as a rectangle, it's the length times the breadth. These little lines here mean that it is that these sides are the same length, so it is a square. So it's 14 by 14, which is 196, 14 squared. Okay, now the area here, the kind of resultant area that's left over for the yellow part, is not going to be an add this time, it's going to be a take away. So if you've ever got a shape cut out, then you're taking away. So we're doing 314.16 minus 196. Okay, so 314.16 minus 196. That's 118.16 squared centimetres. So that's the area of one of those trophies. Now part B goes into say a company orders 450 trophies. One pot of paint covers 5,000 centimeters squared, or square centimeters. How many pots of paint are needed? Okay, so we've got to figure out how much paint are we actually needing for all 450 of these trophies. Well, it's going to be 450 times the amount of paint we needed for one. So times that previous answer. So we're going to take that answer and times it by 450. That's 53,172 squared centimeters. So that's the area, okay, of all 450 trophies put together. Now, when you're buying pots of paint, you have to buy them in full pots. They don't look particularly favourably upon you in a shop when you start taking paint out of the pot. So you've got to buy the full pot. Now, here, if each pot covers 5,000 centimeters squared, we're going to divide this by 5,000. Okay, so we're going to do 53,172 divided by 5,000 to find out how many pots of paint, how many 5,000s go into this. Okay, that's dividing. So dividing that by 5,000 gives us 10.6344. Okay, so I'm just going to do dot dot dot. Now, that means we need 10 point something pots of paint. Like I said, you can't take 0.6 of a pot of paint, so you've got to round up. That means we'll need to buy 11 pots of paint. Okay, and for that kind of question, you've always got to round up. Even if you needed 10.01, you would still have to round up, okay, because you can't just take 0.01 of a pot of paint. Okay, so that's as some examples of how you calculate area. Remember, a few key points. Watch when you're picking your dimensions, your sizes. Make sure you're using the correct formula. Sometimes they're given in a formula sheet. And be careful when you're setting out your working. Make sure you set it out neatly. It will help you a lot later on and when you come into volume. Okay? Hopefully you found that useful. For more videos and resources, please visit www.highschoolmaths.co.uk. If you found this video helpful, please click the like button and don't forget to share it with your friends. Thanks for watching and have a mathemagical day.